Here we learn what is vapor pressure, saturation vapor pressure. Vapor pressure is water vapor pressure. Pressure is the total weight of air molecules. Vapor pressure, yeah. Here is show you weather elements, temperature, dew point temperature, relative humidity. We want to learn these three things and what are the relationship among temperature, dew point temperature, and relative humidity. Yeah. So here give you the chart. The the temperature is 43. Dew point temperature is 31. Relative humidity is 65 percentage. So first we got some picture. So you see this 33 is temperature Fahrenheit. Yeah, 43 Fahrenheit. And this is the green part is dew point temperature 31 Fahrenheit. Temperature 43, dew point temperature 31, then relative humidity is 65%. Yeah. So you see these three relationship relationship between these three parameters. How about here? What's your guess? What is the temperature? 70 Fahrenheit. What is the dew point temperature? 47. Yeah. So temperature 70, dew point temperature 47. What's your guess about this uh, relative humidity? 50%? No, should be more than 50%. Oh no, 30%. Yeah. This is 42%. 42%. Here, temperature is 61 Fahrenheit. Dew point temperature is 54 Fahrenheit. What's your guess about the relative humidity? You see, this dew point temperature and the temperature is pretty close. So this relative humidity is higher. Yeah. How about this? Temperature 68. Dew point temperature is 52. What's your guess about this relative humidity? Yeah, that's a 56. Then you see the relationship between these three weather elements: temperature, dew point temperature, and relative humidity. These are very, very important. We want to learn about this. The big question is how much water vapor can be held in air? So the ability is limited. Ability of the air to hold how much water vapor is limited. There's a maximum. Yeah. This is called the capacity of air holding water vapor. Yeah. What determines this capacity? That's a big question. Vapor pressure. We want to learn vapor pressure. What is vapor pressure? Total weight of water vapor per unit of air. Yeah, how much water vapor in the air? That's vapor pressure. This chart in the x-axis is temperature. In the vertical is vapor pressure. Yeah. So this red curve is the saturation vapor pressure. So here, then we see. Here, give you an example. There's a vessel hold water. Yeah. At temperature at 30 degrees C. Yeah, we want to use this degree C, not Fahrenheit. And above the water, we assume that is dry air. Dry air. That means no water molecules. What's the total weight of water vapor molecule in the dry air? Tell me. What is total weight? Zero! Because there's no water molecule there. So the total weight of water vapor molecules is zero. It's zero. That means vapor pressure is zero. Yeah. What degree C? 30 degrees C. So we use EA to express vapor pressure. Yeah. Under such a case, at 30 degree C, in the dry air, there's no water vapor. Total weight of water vapor is zero. So vapor pressure EA is zero. Okay? So you have to understand in this chart. Not real. Water molecules will be evaporate into the air. So there some water vapor molecules in the air. So the air is not dry air. It's the moist air, right? Some water molecule there. Total weight of water molecules is not zero, right? Yeah. Now the total weight of water molecules is vapor pressure. So vapor pressure is larger than zero, right? Yeah. So this keep this water evaporation to continue. More water molecules will be evaporated into the air. What's your guess? EA is going up. The weight is become more. So the more water molecules go to the air eventually. So the number of water molecules entering the water and leaving the water is the same. Is a balance. We call that the saturation. So this air just can hold so much water molecules. If more, they will get back to the liquid water. So this vapor pressure is called saturation vapor pressure. Yeah. Any point on the red curve is the saturation vapor pressure. This saturation vapor pressure is the function of temperature. Yeah, is different temperature have different saturation vapor pressure. That means this air has different ability to hold how much water vapor molecules can hold. Just like glass. Small glass, big glass, they can hold different amount of water. Right? So this saturation pressure is the function of temperature. So this hot air can hold more water molecules. Yeah. Cold air can hold less water molecules. Right? This capacity of air holding water molecules is determined by temperature. Yeah. Temperature determines the capacity, ability of the air holding water vapor. That's very, very important. Hot air can hold more water molecules. Why does hurricane always generate in tropic, in this area? Because it's hot. Hot air can hold more water molecules. Hurricane. Strong wind and huge rain. Water. Yeah, hurricane means a lot of water. The water vapor condenses into the liquid water. Right? Yeah. So no hurricane is generated in the high latitude, in Canada, in Alaska. No. The temperature is too low. This air only holds a little water. Yeah. Can produce a little water, release a little heat. That cannot produce the hurricane. Yeah. Hurricane is huge water. Strong wind. Strong wind is driven by latent heat, released by water vapor condensed into the liquid water. Huge water vapor condensed into huge water. So release huge latent heat, driven strong winds. Yeah. This year, you know this. At the same time, there's a 1, 2, 3, 4, 5 hurricane. Yeah. Occur. Why? Tell me why. Global warming. Because warming air can hold more water molecules. What's that? 5 hurricanes. Each hurricane, there's so much water molecule condensed into the liquid water. At the same time, because hot air can hold more water molecules. So these 5 larger hurricanes can occur at the same time because hot air can hold more water molecules. Right? Yeah. So now you can understand this is so important. The concept is hot air can hold more water molecules.